All right, we are going to work on 5.6% and estimation. It is very similar to yesterday's lesson, or 5.4, regarding computing in your head. What I want you to see here is that of the vocabulary words, compatible numbers. Compatible numbers can be seen in a multitude of different ways. Particularly the way that we're going to look at them today is that they are numbers that can be divided mentally. Sometimes when you're dealing with compatible numbers, you're talking about numbers that work together, that have some nice common format of some kind. But specifically what we want to talk about today are nice numbers. What numbers are nice that work together? 30 and 5 are compatible because they can be easily divided, just as 40 and 4 and 75 and 3. You can come up with a list of them if you wanted to. 20 and 60, because 20 can go into 60, so those numbers would be compatible. If I wanted to find something that could be divided into, or that 720 was divisible by, I'd want to pick some numbers that could go into 720. For instance, 10. 10 goes into 720. 72 goes into 720. 9. So you would just have to choose what numbers happen to work for whatever situation you're working on at the time. And that's what this is all about. So I'm going to block the screen here for a minute, and we're just going to talk about the problem. Estimate. Well, when we're estimating, that gives us the liberty to change the numbers up a little bit. Now, I'm not going to go and change this here into let's say 50, because that doesn't make sense. It's not even close. It's not near what I'm looking for. I want my number to still be somewhat realistic. So as I look at this number, a few things pop into my mind. I know 20 is pretty close, so 20 seems reasonable and realistic. What other numbers might be realistic? 15. 15 could potentially work, but it depends on what I'm trying to solve. So let's look at the rest of this problem. 30. So which one of these is going to go best with 30? Well, if I did 15 over 100 and I reduce those, I'm going to get 3 over 20. Now, does that work with 30 very well? No. It might work with a different number, but it doesn't work with 30 very well. So let's think about 20. And again, the reason this would be mentally or estimation is that we're trying to do as much as we can in our head. What can we remember? 2/20 is the same as 2/10, or 1/5, both of which work with 30, because this denominator, which has to go into this 30, 10 would go into 30, and 5 would go into 30. Let's say I chose to find 2/10. Well, I could find 2/10 of, multiply 30. This would be like 30 over 1. And remember our fractions. We multiply straight across, but we can cross reduce. 10 goes into 10 once. 10 goes into 30 3 times. And listen to those key words. Go into. It's the same as divide. 30 divided by 10. 10 goes into 30 3 times. Then I need 2 of those groups. 2 times 3 is 6. So we would find this answer to be 6, estimating it to a number to make it nice and easy. Now, could I find 19%? Yeah, but I'd probably have to use a calculator or a lot of little tedious work. How about if I went with 1/5? 1/5 of 30, in this case, would be 1/5 of, again, multiply 30. You don't always have to write the 30 over 1. I'm just holding it as a place value now so you can see how I'm computing the problem. Here I want to cross reduce. 5 goes into 5 once. 5 goes into 36. Into 30 6 times. And then 1 times 6 is 6. Same answer as above here. So it doesn't matter which method you choose. Why is that? Well, 2/10 and 1/5 are equivalent. They're the same. They equal each other. So they should give us a result that is the same, no matter what we do there. All right, let's try this problem. In class, we had set up a little word problem deciphering like this for most of our word problems, for most of our examples. So let's work with it. 25%, right off the top of my head, I think that this is a pretty nice percent. I know 25% makes 1/4. Now, this may not be. We just have to keep working and see. But hopefully it'll work out. I know that 41, because I learned this rule that if a number has a 5 or more, I round up. And if it doesn't, I either keep it the same or round down, depending on what I'm rounding to. So in this case, I'm just going to say that it's closer to 40, because 41 is much closer to 40 than it is to 50. Again, we're estimating, so I just want to find something that's pretty close. 25% we already established is 1/4, so now I have 1/4 times 40. Remember how the 40 would always end up over the 1 and we would just cross divide? Or cross reduce, I apologize. 40 divided by 4 would be 10. 10 times 1 is 10. So 1/4 of 40, if I took 40 and broke it up into 4 groups, I'd have 10 items in each group. All right, we're not going to solve each one of these for its exact answer. I'm just going to help you do the estimation. Now, I'm pretty sure in 6th grade, one estimation for this is not going to be this. Most 6th graders are not going to run to 66.66%. Once I give it to you, most of you are like, oh yeah, that's 2/3. That's pretty easy. 66.66% is 2/3. And then 76, I have a few options. 76 is pretty close to 70, 75, and 80. I've included the 70 because most of us try to, when we're estimating, get it to a 0 or a 5 of some kind. Well, which one of these numbers, 70, 75, or 80, is compatible with our 2/3? Which one's going to work out the best? 70, well, that can't be divided by 3. And 80, it can't be divided by 3. So process of elimination leaves us with this. Can this be divided by 3? Let's just do some math quick. 7 plus 5 is 12. 12 divided by 3, yeah, that would work out. So 75 can be divided by 3 because 12 can. How many times can 3 go into 75? Oh yeah, we're being silly. 25. And how many groups of 25 do I want? I look at the numerator because that tells me how many parts. I want 2 of them. So 2, 25 would be 50. All right. Oh, sorry, I thought I had fixed most of the backgrounds there. Let's just change that up really quick. And we'll hide some things. All right, maybe you already went back and paused it. Or maybe you're just watching as we go along. Let's find some numbers that will work with this. We have to estimate again. Right away, I see that 24 is pretty close to 25%. But in case that doesn't work, I could try 20%. And I can try 30%. I want to try the percent that's always closest, but this might be what I have to do. It looks like I'm close to 40. It looks like I'm close to 45, maybe even 50. But in this case, I notice something. I notice all of a sudden that 25 is like 1/4. And that 44 has 2 4s in it. Well, are these compatible the way they are? Sure are. 44 divided by 4 is 22. All right. Okay. Evidently, I got sidetracked when I was changing all those screens over. Okay, here we go. Estimate 40% of 49. Let's see, 40%. Well, I could leave it as 40% because the one thing running and jumping in my brain right now for 40% is that this would be 40 over 100. And 40 over 100 reduces into 4/10, but that even reduces into 2/5. And then I notice this number is pretty big and it's awfully close to the number 50. It's going to take time. You just have to practice and take time. On your homework, I said that the main thing I want to see is what numbers did you choose to be nice numbers? How did you decide what you were going to do? 50 over 5. 50 divided by 5 is 10. I want that group twice, so I want 20 for total. Alright, for this one, I'm not going to solve the whole problem. We're just going to talk about what would our nice numbers be. So, here, 65. 65 can't be all that bad. It already has a 5 at the end, so it's already pretty close to being rounded. This 13%, in my mind, is pretty ugly. I've had some kids suggest turning it into 15%, but for me, 10% is easier. Because I know, okay, I'll end up solving this one anyway, that 100% of 65 is 65. 100% is the whole thing, and the whole thing is 65 is 65. Well, 10%, how do I get there? I just came in once for my decimal, so how am I going to find out how much 10% is? I'm going to come in once. I'm at 6.5. So that's a lot easier because I don't have to change both numbers. So that's how I would solve this one. Some of my kids during class wanted to turn this into a 15, and it's possible. It's just going to lead to some extra steps. All right. I think I'm going to end there, and I will put on the second part of 5.6, which, well, let's see. I've got 14 minutes. All right. We've got plenty of time here. This is also day 2 then of the lesson. So most classes received the first half on day 1 and the second half the next day. We have to still find some nice fractions, some nice compatible numbers that are going to work for this, that I know the percentages of. 8 over 25 doesn't reduce into anything for me, but it's really close to 8 over 24, which does reduce to 1/3. And this is one of those fractions that you should just know. You should just know that 1 divided by 3, or 1 over 3, is 33.3 repeating percent. So all we have to do this time is take our fraction and turn it into a nice fraction that we know. Again, page 268 would be pretty helpful to know what some of those conversions were, some of those nice fractions were. 14 out of 25. 14 out of 25. What numbers are those close to? 14 out of 25. I have to think for a minute, but this is pretty close to having a 5 at the end of it. So what if I tried 15 out of 25? 5 goes into that, 3/5. Oh, yeah. Now go back and look on your page 268, or some of you might even know this. 5 would go into 3 or 30 6 times, or 60%. All right. So take the fraction, find a nice fraction that would work, reduce it or just convert it, whatever the case might be. So the next problem. Oh, I thought I had that done there. Okay, 89 is pretty close to 90. That's pretty easy. So what could I do with the 120 that'll make it close to this? Ah, wait, 12, 9, and 12. Something has to happen there. So I'm going to do 120. I'm going to divide by 10. 9/12. And what goes into both 9? Oh, 3. 3 goes into here, 3. 3 goes in here, 4. Ooh, do you know this one? I hope you do. 75%. So just took some time, but just think, what are they close to? What would work well together? What might be compatible? 7 out of 57. 7 out of 57. So let's think of our multiplying. 6 times 8 is 48. 7 times 8 is 56. Oh, that's pretty close. So what if I change this to be 7 over 56? 7 over 56 would be the same as 1/8. And if you happen to remember that one, great. If not, look it up. And it is one of those common ones at 12.5%. Okay? So some of these we need to memorize. Some of them we just need to work with. Alright, just due to time, I'm not going to finish those word problems, but I wish you the best of luck.